Hey everyone! Today, we're going to put on our detective hats and solve a pretty wild mystery. But here's the twist. Our main tool isn't a magnifying glass, it's statistics. Let's jump right in.
Okay, so can statistics really help us speak to animals? Well, no, not literally. But what if I told you we could use data to, translate their behavior, to actually understand the stories they're telling us with their actions? That is exactly what we're going to dig into today.
All right, so our story kicks off with a call for help. A zookeeper is pretty worried. See, they just introduced a new African-painted dog to the pack, and ever since, something just feels off. The zookeeper has this hunch that the pack has gotten way more aggressive.
But a feeling just isn't enough, right? The zookeeper needs actual evidence. So they bring in a data scientist to answer this one huge question. Did the new dog actually make the pack more aggressive? This is our mystery. Now, our data detective can't just watch every single dog 24/7. That's impossible, right? It's just not practical. So they have to be smart, really smart about how they gather their clues. And this is where statistics becomes our toolkit.
First things first, we need to define let's call it our crime scene. In statistics, this is called the population. It's the entire group we're interested in. So for this mystery, our population is the whole pack of African-painted dogs. Every last one of them.
But since we can't study the entire population all the time, we take what's called a sample. Think of it like a detective taking fingerprints from just a few key areas instead of dusting the entire room. We randomly pick a group of dogs to watch at different times, and that gives us a snapshot of what the whole pack is up to.
And it's really important to know how our detective is gathering these clues. They aren't running some big experiment or changing the dog's environment. No, they're doing what's called an observational study. They're simply watching and recording what happens naturally. And believe me, this distinction is going to be super important later on.
Okay, so the method is set, and our data scientist has collected all the observations. The clues are in. Now it's time for the big reveal. What does the evidence actually show us?
And boom, here it is, our first major clue. This chart shows the amount of aggressive behavior before the new dog showed up versus after. And wow, look at that jump. It goes from about 13% all the way up to over 22%. Just looking at this, it really seems like the zookeeper's hunch was spot on. Something has definitely changed here.
Let's put a hard number on that jump. We're looking at an increase of 0.096 in aggressive behaviors. That's a pretty big leap. The zookeeper's gut feeling is starting to look pretty solid, backed up by the data. But, a good detective never jumps to conclusions.
And this is where the real detective work begins. This is the moment we separate a simple hunch from a rock-solid conclusion. Yeah, we saw an increase, but could it have just been a random fluke? We now have to build the case against pure coincidence.
Seriously, this is the question that keeps every data analyst up at night. Was this change just a coincidence? A fluke? Animal behavior can be random, right? Maybe we just happen to be watching on a couple of really grumpy days. How can we possibly be sure that what we saw is real?
Well, to answer that, we use this really cool tool called a p-value. Think of it as our coincidence detector. It tells us the probability, the odds that we'd see a jump in aggression this big purely by random chance. So a really small p-value means it's super unlikely to be a fluke. It means something real is probably going on.
And for our dog pack study, the p-value is 0.046. So what does that mean? It means there's less than a 5% chance that this is all just random noise. And in the world of statistics, that's a pretty common threshold for saying, hey, pay attention to this. Because that number is so small, our detective can confidently say the change is statistically significant. It's very, very likely a real pattern.
So, the evidence is in, it's been analyzed, and the case against coincidence is strong. It is officially time for our data detective to walk back into that zoo and deliver the final report. And the report is super clear, laid out step by step. First, we absolutely observed an increase in aggression. Second, that increase is statistically significant. It's not just a fluke. And that leads us to the third crucial point. We can now say the new dog's arrival is associated with more aggression.
But hold on, here comes maybe the single most important lesson in all of statistics. It's a phrase every data detective has tattooed on their brain. Association is not causation. This is the twist in our mystery.
So what does that mean? Well, it gets right to the heart of our investigation's limits.
Remember way back when we said this was an observational study? We were just watching, right? Because we only watched, we can't prove the new dog caused the aggression. The two things are definitely linked, sure. But could something else be the real culprit? Maybe a change in their food, or the weather got hotter. Our study just can't rule those things out. All we know for sure is that there's a connection.
So in the end, we solved one mystery. But we kind of uncovered a deeper one, didn't we? The data gave us a powerful clue, but not the final answer. And it teaches us to look for patterns, but also to really question what they truly mean. So I'm going to leave you with this thought. What story is the data all around you trying to tell?